When first introduced, the TDS 400 set new standards for power and friendliness in a mid-range scope. Now, version 2.1 firmware and hard copy options add even more power and convenience. FFT, roll mode, template testing, and new documentation support are just a few examples of these new capabilities. Stay tuned for the last 5 minutes of this videotape to learn more about version 2.1 firmware.
For over 40 years, Tektronix has brought you high-quality oscilloscopes to meet the most challenging design, research, and testing problems. The TDS 400 digitizing oscilloscopes, the entry models of the TDS family, embody all the attributes of the higher performance members, including high-performance acquisition systems, powerful computing engines, high-performance triggering, and intuitive operation. These attributes give TDS 400 users 4 channels of high performance at a price typical for a 2-channel scope. The TDS 400 line consists of 2 products, the TDS 420 and the TDS 460. Both have 100 megasamples per second on all 4 channels, making them very powerful for 4-channel single-shot applications. The TDS 400 scopes have very high-quality front-end amplifiers. The TDS 420 has 150 MHz bandwidth, while the TDS 460 has 350 MHz bandwidth. Both scopes have up to 30 K-points record length per channel. They have very high-quality VGA displays and graphical user interfaces that make them exceptionally easy to use. Their portable package makes them ideal for rugged field applications. The TDS 400 front panel looks like traditional scopes. Notice the standard layout of the sections: the vertical, the horizontal, and the trigger section. If you're used to using traditional oscilloscopes, you'll find it easy to transition to this digitizing scope. TDS 400 scopes have a number of automatic features. AutoSet automatically sets up your signal with just the press of one button. It looks for activity on all the channels, then sets up the signal automatically in the vertical and horizontal. AutoSet sets the time base and the trigger level, so the signal is acquired automatically and displayed for direct analysis. Besides AutoSet, other buttons at the top of the scope access advanced functions. The Help button gives you instantaneous help text. It's like having an online manual for every function on the scope. Help lets you get to know what each button and knob does just by touching the control. The Help text gives you information about that particular function and what it can do for you. This function button saves and recalls waveforms. You can save a particular waveform as one of 4 reference waveforms. Recall it by pressing the More Waveform button and selecting the desired reference waveform. Notice that now we have a reference and a live waveform back on the screen. Save Recall also allows you to save up to 10 front panel setups. This convenient function is very useful for automatic testing or for field testing, where instrument setup time is a premium. Other advanced function buttons include the Measure and Cursor buttons, which we'll cover later. One advantage of a DSO is its ability to do hard copies. TDS 400 scopes will do a hard copy at the push of a button. TDS 400 scopes give you instant feedback at every functional level. When you press a front panel button, the menu for that function appears at the bottom of the screen. For instance, when we press the vertical button, a menu for vertical functions appears. When we press a bezel button at the bottom of the screen, notice that the menu on the side of the screen changes. This area shows the options available for that particular vertical function. The menus are never more than 1 level deep, making it easy to find the function you want. Obviously, with a 4-channel scope, You would like a fast and easy way of enabling and disabling traces. For instance, right now channel 1 is active. We can turn it off or disable it by pressing the waveform off button. To enable it again, we just press channel 1 on. To enable channel 2, we press channel 2. To reduce front panel clutter, the TDS 400 scopes have multiplexed controls for common channel functions. Simply put, this means the same vertical controls work for each channel. The only thing that changes is the selected channel. Thus, if we want to position channel 1, we select channel 1 and position it. The position control works like it does on a traditional scope. If we want to position channel 2, we select channel 2, then position it. The same method applies to vertical sensitivity. To adjust vertical sensitivity for channel 1, select channel 1 and adjust it. To adjust channel 2's vertical sensitivity, select channel 2 and turn the knob. To adjust the time base, we use the familiar-looking horizontal scale knob. Like a traditional oscilloscope, you turn it clockwise to get a faster sampling rate or faster time base. To slow down the time base, turn it counterclockwise. The third familiar-looking section of the TDS 400 scope is the trigger section. The trigger knob lets you adjust the scope trigger level regardless of the current function menu. So for fast, easy trigger setup, you use this control. The trigger level is clearly shown in the voltage level readout on the screen. Currently, the scope is in auto trigger mode, which is the power-up default. A trigger is automatically generated, so a trace is always displayed. You can also select normal trigger through the trigger menu. In the normal mode, the scope stops updating until it gets a trigger. This is very useful when you need to look for a special event before the scope triggers. You can set the trigger level to a particular voltage, and when the event crosses that level, the scope triggers and updates the display. By using the trigger menu, you can access other trigger functions like trigger source. We can select any of the trigger sources from channel 1 to channel 4. By selecting More on the menu, we access trigger functions like line triggering. This is useful in power applications. You can also input an auxiliary trigger through the connector on the back of the scope. Every input can be coupled in different ways. This is very useful for triggering on noisy signals. Here's an example. Notice on this noisy signal that occasionally the signal jumps because the scope triggers on the noise. One way of avoiding this problem is to use trigger filtering capabilities. Since the signal has some very high-frequency noise, we can use high-frequency reject, like this, to obtain a stable signal. A key thing to remember about the design of Tektronix oscilloscopes is that there is a dual signal path to the digitizers and the trigger circuit. The signal is only filtered in the trigger circuitry to stabilize the trace triggering. The signal is not filtered at the acquisition input. So, regardless of the filtering selected, the displayed signal is not modified. In this section, we will cover some of the features that can improve your productivity. There are key features in the TDS 400 that allow you to detect problems and also to analyze problems much faster than previous scopes. A key feature of the TDS 400 is the ability to acquire signals in various modes. To change acquisition mode, press the Shift and the Acquire menu button. The scope displays the available acquisition modes on the right of the screen. The default acquisition mode for the TDS 400 is sampling. TDS 400 scopes have special hardware that allow them to do peak detect. In peak detect mode, the scope samples the signal at the maximum sampling rate, regardless of the time-based setting. This allows the scope to pick out and display glitches as narrow as 10 nanoseconds. This is true even at sweep speeds down to 5 seconds per division, where the signal of interest can be as long as several hours. Notice in sample mode, we don't see the glitches. Switching back to Peak Detect immediately reveals the glitches and peaks. While Peak Detect shows peaks or glitches over a single sweep, Envelope mode accumulates peaks over a number of sweeps. This is particularly useful if you want to analyze the noise and jitter of a signal over a long period of time. High-res mode is a feature unique to Tektronix. High-res uses hardware digital signal processing to achieve up to 15 bits of resolution at slower time-based settings. It does this by dramatically improving the signal-to-noise ratio. Notice on this signal that the noise level is substantially reduced. High-res mode achieves this noise reduction through on-the-fly averaging. The same kind of noise reduction can be achieved by using averaging mode. However, averaging requires a number of acquisitions which slows down display update. The advantage of high-res versus averaging becomes clearer when looking at modulated signals. Here you see a modulated signal in average mode. As expected, averaging improves the signal-to-noise ratio, but all modulation information has been averaged out. In contrast, when we switch to high-res mode, the display shows the rate of modulation and the improved signal-to-noise ratio. Again, this is a result of on-the-fly averaging on a single acquisition. The TDS 400 has powerful measurement capabilities. We'll examine these features using this staircase signal. Let's look at the cursor measurements. To select the cursors, simply press the cursor button on the front panel. You can then select either horizontal bars or vertical bars. We'll select horizontal bars to make voltage measurements. To position the horizontal bars, we turn the general purpose knob. To select the other cursor, we press the toggle button. At the top of the screen, the scope shows the delta volts between cursors. The readout also shows the absolute voltage of the selected cursor. For time measurements, the same technique applies, except we use vertical cursors. Once again, you have the ability to do delta measurements between the cursors. The readout also shows an absolute time measurement. This measurement is referenced to the trigger point. Now let's look at some of the sophisticated measurements available through the Measure menu. There are 22 possible automatic measurements on the TDS 400. You can scroll through them by pressing the More key at the bottom. They're easy to understand because they're clearly illustrated with icons. For our first measurement, we'll select Peak to Peak. The scope displays the measurement as taken from the top to the bottom of the screen. But let's say we wanted to measure a particular part of the staircase, for instance, one level transition. We can do this by using gated measurements. This technique uses some of the functions we've already talked about. First, we'll clean up the signal by using high-res mode. Now we expand it so we can see the staircase in more detail. Next, we activate the cursors to enable a gated measurement. We will use the vertical bars to gate in time the particular part of the signal that we want to measure. Now we select the Measure menu and enable gating on with the vertical bars. Now the scope takes the measurement between the cursors. The readout shows the peak-to-peak value. As you've seen in this example, gating with cursors is a very powerful addition to the automatic measurements. Until now, we've always adjusted the vertical sensitivity or horizontal time base to see a particular part of a signal. For single-shot signals, the TDS feature Zoom allows you to examine the signal in greater detail. First, we'll set up the scope to do single-shot acquisition. Then we acquire our signal. To expand the signal, we select the Zoom menu and turn it on. Now we can expand the signal. Remember, zooming does not cause the scope to reacquire. It graphically expands the displayed signal. Zoom mode also demonstrates the value of high-res. When we switch back to sample mode and reacquire, notice that the signal-to-noise ratio is extremely low, and the signal is buried in noise. Going back to high-res and reacquiring again, you can see the improved signal-to-noise ratio, which allows us to see signal details. As mentioned earlier, TDS 400 scopes use VGA quality displays, which provide the flexibility of various display formats. For instance, you can choose any of 4 different graticules. A key advantage of the TDS display is a mode called variable persistence. Variable persistence makes use of the ability to modulate the intensity of each pixel on the screen with 16 levels of intensity. So the screen can display traces with intensity proportional to the rate of the signal's occurrences. You can also set the decay rate. This lets you detect variations in a signal like you're used to seeing on an analog oscilloscope. As with other oscilloscopes, the TDS 400 powers up into a Y or amplitude versus time format. But we can also select an XY format for channel 1 and channel 2. This is useful for doing phase correlation. One of the great things about the TDS 400 is that it samples simultaneously on all channels. Thus, your XY data is always time and phase correlated so that the Lissajous figures are accurate. One other TDS 400 capability is video triggering, which allows you to trigger on television signals in NTSC, PAL, CCAM, or even custom video signals. Once you've triggered on the signal, you can make complex measurements. The TDS 400 features you just saw have been expanded by the introduction of version 2.1 firmware. Version 2.1 is now shipped with every new TDS 400 and is available for upgrade into any existing TDS 420 or 460. The new features available in version 2.1 draw upon the superior processing power of the TDS platform to offer unparalleled speed, ease of use, and display update rate, even under the most demanding conditions. An option for version 2.1 firmware is the Advanced Math package. One of the key features of this package is FFT, a real-time frequency domain analysis capability that makes the TDS 400 a powerful analysis tool. Oscilloscope users in many different areas are discovering that using fast Fourier transforms greatly increases their efficiency when exploring the true nature of their waveforms. FFT assists you in searching out sources of oscillations in noisy environments, design and analysis of switching power supplies, and vibrational analysis of rotating machinery. Integration and differentiation functions aid in the analysis of response characteristics. The processing power of the TDS 400 platform provides live math waveforms, letting you see variations as they occur in both the time and frequency domain. On this noisy sine wave, the FFT lets us gather information about the frequency content of the noise and how it varies with respect to time. On competitor scopes, the power of the fast Fourier transform can be limited by the ability to calculate and display the transform. Important information about the variance of the waveform over time can be lost. The Tektronix TDS 400 uses proprietary digital signal processing hardware to ensure such detail is not missed. When you need to capture long-duration events, version 2.1 provides a standard record length of 15,000 points on all 4 channels, with an option for up to 60,000 points record length per channel. The additional capability provided by longer acquisition memories is easy to use. You simply choose the sweep speed that displays the waveform in sufficient detail for the measurement being made. Then select the number of divisions of data to be captured by the press of a button. Once captured, records are easily reviewed using the horizontal position knob. Long acquisition memories, coupled with the TDS 400's 100 megasample per second digitizing rate and peak detection capability, provide up to 1,200 divisions of data capture while retaining details as short as 10 nanoseconds. At the slowest time-based setting, this translates to over 6.5 hours of data capture time on all 4 channels simultaneously. Version 2.1 firmware also gives the TDS 400 pass-fail template testing capability, which is valuable in manufacturing test, research, and design. This feature is useful in monitoring waveforms and capturing events that fall outside a user-defined template. You can easily build templates right on the TDS 400 using acquired waveforms or waveforms imported from an external computer. Templates can also be built on external computers and imported as templates. Out-of-bounds conditions can be used to generate hard copies, store the waveform to mass storage devices and reference waveforms, or ring an annunciator bell. The TDS 400 conveniently places the first out-of-bounds condition at center screen, helping you find the event of interest quickly, even with very long records. You can easily view slowly varying waveforms using the version 2.1 roll mode. Roll mode lets you see changes in the waveform as they occur. The high update rate of the TDS 400 extends the roll mode capability to 50 milliseconds per division, 10 times faster than competitor scopes. And the unique triggered roll mode allows you to combine the convenience of a rolling display with trigger capability to capture infrequent events on slow waveforms. Portable documentation needs are filled by the unique printer pack option housed in a pouch on top of the scope. This provides a single power cord, single handle solution. The printer is a quiet, reliable thermal hard copy unit that produces 4-inch copies at the touch of a button. Another pouch in front of the printer pouch has additional room for a digital multimeter, spare probes, paper, and more. TDS 400 hard copy interfaces enable connection to a variety of devices for obtaining hard copies or for importing screenshots into desktop publishing applications. Tektronix, RS-232, and GPIB are all supported via 14 different hard copy formats, including EPS, TIFF, PCX, and HPGL. Creating reports with actual screen images now becomes easy to do, increasing reporting efficiency. Simply capture your signal into the TDS 400. Export the screen image to your computer, and import that same image into your publishing application. Then develop your report complete with the screen image. Quality reports are that easy to create with the TDS 400 documentation options. In this video, we have covered the majority of the TDS 400 functions. The TDS 400 series is one of many lines of high-performance oscilloscopes available from Tektronix. We have full support worldwide with 3-year warranties. For more information on the TDS 400 scopes or other Tektronix instruments, contact your local Tektronix representative.